Welcome to lesson 4.2. We're going to be talking about solving systems of linear equations using substitution. So when you hear the word substitution, you think about different scenarios that can happen. So for example, when you're playing a sport and you sub in, you're replacing one of your players, right? In volleyball, let's say you're a defensive specialist, then you're going to replace a front row player when they get to the back row. You're a substitute. You're completely replacing that person in that exact position. In basketball, let's say you're the second string point guard. Well, you go in for the first string point guard. So you're replacing that person in that exact spot, right? Or for example, when you get older like me, or your parents, you guys do grocery pickup at Walmart, if they don't have the name brand chips like the Lay's chips, they're going to substitute them for the Great Value potato chips, right? They're replacing what you wanted, right? It's a substitute, okay? So when we're doing this with equations, we have to think about we're replacing what's there with something else, okay? So the first set of the front page, so this front page, we're not actually going to solve these systems. We're just going to work on substituting, and then we'll solve when we get inside the foldable. So there's three different scenarios we have when we can substitute. So we have one equation is set equal to a variable, no equation is set equal to a variable, and both equations are set equal to a variable. So we're going to start with one equation. So one equation is set equal to a variable. We have the system where, let me get my color I wanted, sorry. One equation is set equal to a variable. We have y is equal to 2x plus 1. That's what it's talking about when we have that. So y is equal to 2x plus 1. Okay, so now we're going to look and see, okay, where can I substitute 2x plus 1 into the second equation? Because we can't solve an equation that has two separate variables at the same time. We have to somehow replace it, okay? So y is equal to 2x plus 1. So if we look at our second equation, we have x plus 3y equals negative 12. Well, we can replace y with 2x plus 1 because y equals 2x plus 1. So we're going to substitute, instead of y, we're going to put 2x plus 1 into that equation. So I have x plus 3. Now, instead of y, we're going to put 2x plus 1.
Zion Carvajal, please go to dismissal right away, please. Zion Carvajal.
Thanks. 3 times 2x plus 1 equals negative 12. So essentially, instead of 3y, we're taking what y was equal to and replacing it with that, okay? That's the principle of substitution, okay? That is literally all you have to do for substitution. And once we get here, then now we solve for x, okay? So once we get to that, we solve for x. Now we're not actually going to do that for this one, but we'll do it inside the foldable. So let's go ahead and flip open. So we're going to work on this top set up here. So I have x equals 3y minus 9 and 5x minus 2y equals 7. So we're going to use substitution. These would not be pretty to graph, right? We'd have to rearrange both of them for y. So that would take forever to then have to draw a graph and graph it. So sometimes graphing, although graphing sometimes can be our comfort zone because we're used to graphing, when we have to rearrange the equations a bunch, it's not always the best way. So substitution is another one. I typically recommend using substitution when we have this scenario or this scenario. The other one is typically this scenario. Typically, we would use elimination, but you don't know how to eliminate yet, so you can't use it. So we're going to learn substitution for all areas, and then as you get better with them, you can kind of pick and choose which method you're best with. Okay, so x is equal to 3y minus 9, so I'm going to replace x with 3y minus 9. Okay, so when we do that, I have 5 times 3y minus 9 minus 2y equals 7. So now we're going to solve for y. Okay, so the first thing we're going to do is distributive property. So 5 times 3y is 15y minus 45 minus 2y equals 7. So then we're going to combine like terms. So 15y minus 2y is 13y minus 45 equals 7. So then we're going to add 45 to both sides. So then 3y equals 52. And then when we divide by 13, we get y equals 4. Okay? So that's the first part. Okay? So we're going to take this y equals 4 and now plug it in. Okay? So we have x is equal to 3y minus 9. So essentially, we're going to take what y equals and replace it. Okay, that's what substitution is. So x is equal to 3 times 4 minus 9. So then 3 times 4 is 12, and 12 minus 9, x is 3. Okay, so the solution, my solution to this system of equations is the ordered pair 3, 4. So if we were to graph these two lines would be intersecting and at the point 3, 4. So we can label this system as consistent because there is a solution, and independent because there's one solution. You see, we get the solution 3, 4. That is one solution. Okay, so then I have the second one. I have negative 6x plus 3y equals negative 12, and y equals 2x minus 4. So I have y is equal to 2x minus 4, so I'm going to replace that with y, where y is. Okay, so I have negative 6x plus 3 times 2x minus 4 equals negative 12. Okay. So now I'm going to do distributive property first. So I have negative 6x, 3 times 2x is 6x, 3 times negative 4 is negative 12 equals negative 12. Now, if you notice, I have negative 6x plus 6x. That ends up canceling itself out, right? That's 0. So what's left is negative 12 equals negative 12. And so we have to look at that. That is a true statement. So that means there is infinitely many solutions. Okay, so this is where substitution can sometimes come in handy because we know that's a true statement. So it's infinitely many solutions. So we would label this system as consistent and dependent because we have an infinite amount of solutions, okay? Because there's a true statement. So now let's open up or go back to the front, and we're going to go to no equation is set equal to a variable. So this is where we would have to rearrange one of the equations. Ideally, this would be a substitution problem, but because we don't know substitution, we're going to have to use that. So we're going to rearrange this first equation to y equals. And if you look, we have 2x plus y equals 10. So we would subtract 2x on both sides. So that's y equals negative 2x plus 10. So this, let me change the color, sorry. This piece, y equals, is going to replace y. Okay, so then I have 4x plus 2 times whatever y equals, which is negative 2x plus 10. And it equals negative 3. And then we would solve for x. But we're not going to do that on the front page. We're just looking at what it looks like to rearrange and plug in. So if you have no equation, you have to rearrange one of the equations and set it equal to a variable. Most times there's going to be one variable that's like by itself, its coefficient is 1, and that's the one you're going to go for. Okay, so let's open up to our foldable. So I have 4x plus 5y equals 11, and y minus 3x equals negative 13. So this is the one I'm going to rearrange, okay? And when I rearrange that, y is equal to positive 3x minus 13. Okay, so then what I'm going to do is rearrange this equation, okay, or plug in this equation. So it's y equals 3x minus 13. So now what I'm going to do is take this piece and substitute it in for the y, okay? So over here I have 4x. I have 4x plus 5 times 3x minus 13 equals 11. Okay? So then I'm going to do the distributive property. So I have 4x plus 15x minus 5 times 13 is 65 equals 11. So the first thing I'm going to do is combine like terms. So 4x plus 15x is 19x minus 65 equals 11. So 19x equals 11 plus 65, which is 76. So then I divide by 19 and x equals 4. Okay, once I have x equals 4, I'm going to replace that in your second equation. So I have the second equation, y equals 3x minus 13. But now I know what x equals, so x is going to be replaced by 4. So I have y is equal to 3 times 4 minus 13. So that's 12 minus 13, which is negative 1. So the solution is my ordered pair for negative 1. So we would label this system as consistent and independent. There's one solution for this system. The solution is for negative 1. So it would be consistent and independent. Okay, so regardless of what method you're using, you can still always label the system based on what it gives you, what your solution is, okay? So now I have x plus y equals negative 5. This is one you could choose. You can rearrange for x or you can rearrange for y. We'll rearrange for x, so x is equal to negative y minus 5. Okay, so now we're going to take that and plug it in for x. So in my second equation, I have 4 times negative y minus 5 minus 5y equals negative 20. Okay, so 4 times negative y is negative 4y minus 20 minus 5y equals negative 20. So then negative 4y minus 5y is negative 9y minus 20 equals negative 20. So then I'm going to add 20 to both sides, so negative 9y equals 0. So y is equal to 0. Okay, so then I'm going to take this and plug it in with y. So in my equation, I have x is negative y minus 5. So where y is, I'm replacing it with what y equals. So x equals 0 minus 5. 0 can't be negative, so it shouldn't be that. So x is 0 minus 5, so negative 5. Okay, so my solution is the ordered pair negative 5, x is negative 5, y is 0. So we would label this system as consistent and independent. There's one solution. The solution is negative 5, 0. And so then the last piece is I have both equations are set equal to the variable. So when this happens, both are equal to y. So I'm going to set this piece and this piece equal to each other because they're both equal to y. Because think about it, y equals y, right? So instead, I'm going to replace those as x plus 5 equals negative x plus 3, okay? Both of them are equal to each other. And now we're going to solve for x. Okay, now we're not actually going to do that for this system. You can if you want to on your own free time. We're just not going to for this video. So now we're going to open up. So I have x equals 3y minus 6 and x equals y plus 2. So the first thing we're going to do is set them equal to each other. So I have 3y minus 6 equals y plus 2. Okay, you set them equal to each other. So then I'm going to subtract y on both sides. So I have 2y minus 6 equals 2. Then I'm going to add 6. So 2y equals 8. So y equals 4, right? So I have this set, y equals 4. Now, this is where you get to pick either equation, okay? It doesn't matter which one you pick. It can be either. I'm going to pick x equals y plus 2. And instead of y, you're going to replace it with 4, okay? So I have x equals 4 plus 2, so x equals 6, okay? So my solution is going to be 6, 4. So we could label this system as consistent and independent. There is one solution to this system, and because it has a solution, it's consistent. Okay, so now this next one, I have y equals 2x plus 5 and y equals 2x minus 5. So I'm going to set them equal. So 2x plus 5 equals 2x minus 5. And so if you're going to solve, you would minus 2x on both sides. So then I'm left with 5 equals negative 5. Now, is that a true or a false statement? That is a false statement. So that means that our solution is no solution. There is no solution to this system of equations. And if you notice, their slopes are parallel, so that means they're never going to touch. So that means it is no solution. So we could label that system of equations as inconsistent because there is no solution. So that's it for lesson 4.2. Bye.